Hi, this is Xander Scott from Thursday's Lab at 10 a.m., demoing for Lab 9, Register Bank, and Shift Register. So, the board is currently loaded up with Part 1, and that is the Register Bank. So, what we have here is we have 3 registers that are hooked up that are each able to store and exchange data. So we have the universal clock, which is on key 0, and we have the clear on key 1. We have our input switches on switch 0 to switch 5. Switch 6 and switch 7 are currently grounded as we needed switch 9 and switch 8 to be our input 1 and our input 0 respectively. Switch 7 and switch 6 are output 1 and output 0 respectively. And so what that means is, depending on what we choose here, will affect which input or which register we're storing our data to, and what we are putting in for these two switches, the two output switches, affects which register or which location we are pulling data from. So since our switch 7, switch 6 are currently set to 0, 0, we are actually pulling from our switch inputs, which, as you can see, is reflected properly. And so just set that switch to 1, and our first task is going to be to actually store that 1 into our first register. So we want to leave our output here to be pulling from these switches. So leave it at 0, 0, and our input can be put at 0, 1. So that will store it to register 1. And that should be done. Can confirm by checking. Let's turn this to 0 and check that. Yep, when you set the output to pull from register 1, it is displaying that register 1 has 1 stored now. So next we do 2 on 2. And clock to store it. And let's check that, make sure it's stored properly. When we output from register 2, it sure enough shows 2. And 3, 2, 3. Let's go ahead and store that. And when I output from register 3, it does show 3. Okay, so now we want to actually shift data from R1 to R3. So this means that we want R3 to show 1, so we can go ahead and say that we're actually outputting from 1, and that'll give us our 1 value there. And we want to input into 3. And none of the other switches need to be active because they are not being utilized. Okay, let's go ahead and store that. And let's check that that was stored. So, to check that our input 3 shows 1. So, that means that that has demoed correctly. And now on to part 2. So let me program the board here. And part 2 is going to be our shift register. So what we will have is the LED lights here, see how they just went out, are actually pulling. There are actually multiple registers that will show the data that is stored. We have our switches 0 to 7 that actually store the data in these registers. So we want to start out with all ones for each one of those registers stored. So we still have the same clock that is applied to all of them, and on key 0, and then we have the same clear on key 1. So let's go ahead and that stored all of those. So now we're just going to be moving things around. So our keys here are our shifts. So if we want to shift off to the left, we are going to set these two keys to represent 0, 1, and use the clock to actually change the state. So shift off to the left, and sure enough, and 7 times got it to where it needed to be. And now we actually want to shift off to the right. And to do that, we're going to set our shifts here to 2. So 2 will shift that input off to the right in the different registers. So again, hit the clock to apply that change and shift right. Okay, and that's 7 times shifted to the right. And then if you apply 3, it will not do anything. There should be no change. And let's double check that. Sure enough, no matter how many times I hit the clock, it is not changing. So that is the shift register. That is what is happening with it when it is set to those different states. So that should be the demo for part 2 of Lab 9, as well as part 1.